All right, I'm going to get started. I hope you can all hear me okay. Hello everyone. I hope you had a great morning here at PyCon Canada. Thank you so much for being here for my talk. I'm Anna. I'm from Germany, so I've come quite a long way to be here. I have a degree in English and Catholic theology. Some of you might have wondered why you see Shakespeare and Pope Francis on my slide. But about 2 years ago, I got involved in Python, and until a few weeks ago, I worked as a community manager for an open source project, and I'm currently looking for my next work opportunity. I'm also involved in a few other volunteer-related things. I'm PyCon US Open Spaces Chair. I used to be on the board of directors of the Python Software Foundation. I'm DjangoCon US Communications Chair, and I'm one of the leaders of the PyLadies remote group. And this is my first time in Toronto. I got to explore the city a little bit yesterday, and I had a great time. And I just want to say a big thank you to the PyCon Canada organizers. It's because of their financial aid program that I can be here and talk to you today. Especially a big thank you to David, who made this all possible. So thank you. I'm here today to present my talk with the title Rub-a-Dub, Don't Be Afraid to Debug. I'm pretty proud of this title. It took me a long time to come up with it. Honestly, I think it's pretty cool. So let me show you something first. This used to be me when I encountered a bug in my code. And this is me now. So the goal of this talk is for you to hopefully feel like a warrior and feel strong and brave when you encounter bugs in your code, and to not be scared or frustrated by them. First, let's take a look at what a bug is. Like I said, I'm an English major, so I love definitions. So when you type the word bug into the Merriam-Webster dictionary, you get all sorts of definitions. Here are a few of them on my slide. A bug can be an insect or germ, an enthusiastic, prominent, or crazy person. It can be a concealed listening device or weight allowance for jockeys, or for example. That's pretty interesting. I had no idea the word bug had so many meanings. Unfortunately, we're not interested in any of those today. The one we're interested in is this one. A bug is an unexpected defect, fault, flaw, imperfection, or in other words, something is wrong with your code and causes it not to work. Now we know what a bug is, but what is debugging? It's pretty simple. Let's take a look at the dictionary again. In the context of computers, it basically means you remove a mistake and make your code work. So now we know what a bug is and we know what debugging is, which is great. But if there's one thing I want you to take away from this talk is that bugs are nothing to be scared of, and that there's a way to fix everything. How many of you have been scared or frustrated when you encountered a bug in your code before? Pretty much everyone. So I hope in 25 minutes you'll be more prepared to encounter bugs and fix them. So why is breaking things great? Breaking things is great because it gives us the opportunity how to fix them. I know when I started coding, I was super afraid of error messages. I was super afraid to break things because I had no idea how to fix them. You may not always be able to fix things yourself, but especially in the Python community, there are so many friendly people, so there's always someone who can help you out. Let me tell you a little personal anecdote to kind of emphasize what I mean. So about a year ago, my mom broke the on-off button on her computer. I love my mom, but she's very technically challenged sometimes. And so she had pushed it too far in, and so you couldn't turn it on, couldn't turn the computer on and off anymore. And so I thought, okay, we could either buy a new computer, but it was still too good to do that, or we could take it to the store, but that would take some time and money. So I Googled the problem, and I found instructions on how to take her PC apart. I'm not a hardware person. I had never seen the inside of a PC before, but I was actually able to fix that button. I didn't fix it perfectly, but I fixed it fine enough that it worked. And it still works 1 year later. So apparently I did a good enough job. Now when writing code, you have to keep in mind, it's kind of like that button. You might not always get the perfect solution, but sometimes it's good to have one solution at first, and then you can always go back and make it better. Let's take a look at a few debugging strategies and learn how rubber ducks can be super helpful. And please keep in mind that this is not an exhaustive list of strategies, nor did I take a very technical approach here on purpose. The ones I'm presenting are just the ones which I find useful and which are beginner friendly. Let's start with error messages. In Python, there are 3 types of errors, but only 2 will give you error messages. The first one are the so-called syntax errors. And the slides are going to be up online, so I'm not going to read it out loud for time reasons, but you can find it later. I'll tweet out a link. Python will find syntax errors when it parses your program. It will exit with an error message without running anything. And syntax errors are basically mistakes in the use of the Python language, just like you make spelling or grammar mistakes in English. Let's take a look at a very simple example. So when I run this code, I get the following error message. You can see that the parser repeats the line and displays an arrow pointing at the earliest point in the line where the error was detected. The error is detected at the token preceding the arrow. So we can see that the arrow is pointing at the closing bracket, which means my mistake is after the closing bracket. So you can also see that Python tells us where the error happened. So I'm only executing one file. I call it example1.py, and my error is in line 1. Does anyone know what is causing the error? Sorry, I gave it away. Sorry. I forget a column. Okay. And Python will do its best to tell you where the error is happening, but sometimes it's misleading. So if you don't see anything after to where the arrow is pointing to, just check through your code and check through the previous lines of your code to make sure that you didn't skip anything. The second type of errors are the so-called runtime errors or exceptions. If a program is syntactically correct, which means it's free of syntax errors, Python will run the program. However, the program may exit unexpectedly at any point if it encounters a runtime error. And when this happens, we call it our program is crashing. Let's look at some examples of Python runtime errors. One type of exception or runtime error is the so-called division by 0 error. So we're trying to divide 5 by 0, and this is not possible. And you can see that Python tells us in line 5 what the error is. It gives us very specific, it tells us 0 division error, so it gives us a very specific name for it. You can see in the preceding line, it tells us where the error is happening. I'm running the code from the command line here directly. I'm not running a file, so it says stdin, which stands for standard input, and it's happening on line 1 because there's only one line. And the first line tells us that the error is happening as a traceback. Another type of runtime error is the so-called using an identifier which has not been defined, or a name error. So we're trying to do 2 plus Django Pony, but we haven't defined the variable Django Pony anywhere in our program, and so Python says the variable Django Pony is not defined. Another type of error is performing an operation on incompatible types. So we're trying to do 7 plus 7, but Python says it's a type error because one of the 7s is a string and the second one is an integer, and Python cannot concatenate the 2. 2 other types of runtime errors are accessing a list element in a dictionary value or object attribute which doesn't exist, or trying to access a file which doesn't exist. Whenever we try to read a file or we're asking users for input, we're kind of setting ourselves up for errors because users cannot always be trusted. And good programmers should add safeguards to their program to prevent these errors from happening and to prevent your program from crashing. If we know that a particular section of our code is kind of prone to errors, or it's likely to crash, we can do something about it. And in Python, you would do this with a so-called try and except block. So first, the try clause is executed and the user is prompted to enter a number. If no exception occurs, that means if the user actually types in a number, the except clause is skipped and the try statement is executed. But if an exception occurs and our user doesn't type in a number, meaning if the user gives us wrong input, then the except clause is executed and the rest of the clause is skipped. So you can see that I was prompted to type in a number and I entered Anna, which is not a number. So then instead of crashing, our except clause was executed and Python told me, sorry, that was not a valid number. And then I was prompted to enter a number again, and the second time I did it right, and it typed in number 3. So the first clause was executed right away, and the statement was finished. And there's a third type of errors in Python, which is probably the hardest to debug, and there's the so-called logical errors. They occur when the program runs without crashing but produces an incorrect result. The error is caused by a mistake in the program's logic, and Python won't actually give you an error message for this one. That's why it's kind of hard to debug, because you will have to find the problem on your own by just looking through your code. And I gave you a few examples of logical errors on the slides, which you can look at later if you like. This is just a very small introduction to error messages. If you'd like to learn more, I recommend checking out the Python documentation or the Python textbook. So most of the time, you'll be able to figure out what is wrong with your program by just reading the error message, but that's not always the case. Sometimes Python will give you an error message and you still have no idea what is wrong. So what do programmers do when they don't know what to do? They turn to Google. So Google can be a great debugging tool, but it's actually only helpful if you can tell it precisely enough what is wrong with your code. Sometimes you may be able to describe your problem in 2 paragraphs, but that's too much for Google to process. So in this case, you are probably better off turning to a friend. But sometimes it's super helpful to just take the error message and paste it into Google, and Google can help you out. So let's look at an example. This is me explaining to Google very poorly what is wrong with my code. I made some changes to my code, but I can't access my website on the internet, and I don't know why, and it's really frustrating. Please help me, Google. I'm over-exaggerating here, but you can see my point. And I get results which are not helpful at all. They don't have anything to do with Python or programming, really. In my second step, I'm giving Google you can see that my search request is shorter, and I'm giving Google keywords like Django, for example. So the results that I get are actually about Django. They're still not very helpful. And in the third step, I tried to explain it very precisely. Django can't access development server in browser, and I get super helpful results. All 4 of them are Stack Overflow results, and all 4 of them were actually very helpful. Okay, so now let's talk about what this talk is actually about, rubber ducks. So if you've never heard of rubber duck debugging, you may think it's sort of crazy, but it's actually pretty helpful concept, and it works. And programmers love and swear by it. So the idea is you have a little rubber duck sitting on your desk, and when you don't know what is wrong with your code, you try to explain to your duck what is wrong, and you have a little conversation with your duck. And by speaking out loud and kind of processing it, putting it into spoken words, you often can either think of the solution yourself, or you will at least be able to get a more precise idea in your mind, so you can explain it to someone else, or you can Google it. What's also good is discussing different hypotheses with your rubber duck. So look at your code and make a list of different hypotheses. What could possibly be wrong with your code? What could be the cause of your code not working or crashing? And what could be a possible solution? And then start working through these hypotheses and talk them through with your rubber duck. I'm not joking, it actually really works. And because this talk is all about rubber ducks, and we all love rubber ducks, I actually brought some for you. They're pink, which is my favorite color. I thought yellow was kind of boring. And what's cool about them is that they don't have faces yet, so you can draw on them, personalize them. I don't have enough ducks for everyone, but if you like one and you don't have one yet, please come and see me after my talk, and I'd love to gift one to you. Now, when you test different solutions or different hypotheses, it can often be helpful to break down your code into smaller pieces. Identify self-contained sections of your code, like functions, for example, then comment out different sections and run them. Insert print statements to see if your code is actually doing what you think it's doing. It's much easier to debug, let's say, 10 or 20 lines of code than to look at 500 lines of code and get totally overwhelmed because you don't even know where to start. And while you write code, it's always good to execute your program after a certain number of lines. So let's say write 20 lines of code, then execute the program. If it's fine, write the next 20 lines of code. If you get an error, then you know that your error is probably happening in the last 20 lines you just wrote. When all else fails, you can start with a new and empty file. Just take your code, which is broken, and start copying and pasting it into a new and empty file and execute the file and figure out where your error is. What can also be helpful is writing pseudocode. So in order to debug your code, you need to understand your code. So take your code and write comments and figure out what your code is actually doing. One second. If you're debugging someone else's code, it can also be helpful to draw diagrams. So take those, let's say you broke down your code into chunks and then you wrote pseudocode to explain to yourself what your code is doing. And your next step is you draw a little diagram. I do this on paper because sometimes paper is more helpful than doing everything on a screen. You just take paper and see how your different blocks of code interact, in which order are they executed, and this will help you understand your program and will help you debugging it. When you're following a tutorial or the documentation and you run into a bug, there are two possibilities. Either there's a bug in the documentation or tutorial, or you made a mistake. So when this happens, ask yourself the following questions. Is the indentation correct? Did I forget any commas or brackets? Are there any typos? Or did I leave out a whole line of code? This happens all the time, especially when you're actually not copying and pasting code, but just typing it from a book or from some other tutorial or the documentation. After you double check everything and it's still not working, check if the documentation is on GitHub. So this is the Django Girls tutorial. It's on GitHub, and what I would recommend is checking the issues. And if someone else ran into the same bug as you and they reported an issue, then you can almost be certain that it's most likely and the issue was responded to, then it's certain that it's not you who made the mistake, but it's actually in the tutorial. And what you also did is you did some good because you helped other people, you reported the mistake, and it can be fixed. And if it ends up not being a mistake in the tutorial, actually don't be afraid of still reporting it. Most maintainers are pretty friendly, and they'll just say thank you, and they might be able to actually help you figure out what is wrong with your code. You may have heard people talking about reproducing bugs, but what does that really mean? So let's say you found a bug and reported an issue, but before anyone will try to fix the bug, what they will do is reproduce the bug, and it took me forever to figure out what reproducing actually means. Reproducing is basically they take the bug, and ideally you explained in detail what is wrong, and you explained step by step how you get to encounter the bug, and they will follow these same steps in their development environment on their computer. And reproducing bugs has two big benefits. First of all, they follow the same steps, so they can figure out what you did, and they might be able to help you if you made a mistake. And the second benefit is that they won't try to fix something which doesn't need fixing. And like I said, they may be able to help you because they will go through your approach step by step and may figure out where you made the mistake. Debugging will teach you a ton. Sometimes you may even realize that something you thought works in Python actually doesn't work in Python. This happened to me a lot before. And making mistakes is a good way to gain knowledge and to learn new things. So don't be afraid of making mistakes. These approaches I talked on are pretty hands-on. They're not very technical, like I said in the beginning, but of course we're programmers and there were other smart people who wrote debugging tools. So these are just a few that you can take a look at after this talk if you like. I'm not super familiar with them, but I just wanted to mention them in case you wanted to take a look. Errors in your code and debugging can be super frustrating. We've probably already all been there when we just wanted to smash our laptop and be done with it. And I saw someone say on Twitter that that when you code, sometimes you feel like a superhero and the next day you feel like an absolute failure and loser because you just can't get your code to work. And that is true. But how do you deal with frustration in a healthy way? Because frustration is a natural part of being a programmer, but dealing with frustration every day and being frustrated every day isn't very healthy. So how do you prevent frustration, or what do you do when frustration kicks in? Obviously, everyone's very different. These are just some suggestions or what I do. First of all, I would like to recommend that you ask for help after a certain amount of time. Take 30 minutes and try to figure it out by yourself, but don't sit there for 3 hours and get frustrated. If you can't figure it out after 30 minutes, either step away or ask someone for help. I saw this on Twitter the other day. One of the best programming skills you can have is knowing when to walk away for a while. And I think this is very true. Go for a walk, read. I like to color in my adult coloring book, take a nap, do something that has nothing to do with coding at all. Something you enjoy just to free your mind. Go to your happy place. This is one of my happy places. Obviously, I don't get to go there every day. A lot of times I go to bed and then I wake up the next morning and I look at my screen and I can see what was wrong all along, whereas the night before I had totally struggled with it. Do you know that feeling when you write, let's say you write a text and you read it 10 times and you're absolutely sure there are no mistakes in it, and then you gave it to a friend and they find a bunch of spelling or grammar mistakes. Sometimes when we look at our screen for too long, we get blind to our own mistakes. So that's why it's helpful to walk away for a while. And when you ask someone for help and they give you an explanation and you don't understand it, don't think that it's you, that you're too stupid to understand the solution, and don't think that it's them. So I'll tell you a story. When I started learning Python, I did the Code Academy Python tutorial, and there was a section about binary numbers in there, and I had never heard of binary numbers before. I didn't understand it at all. So a friend of mine tried explaining it to me for a whole night, and by the end of the night, I was frustrated because I still didn't get the concept, and he was frustrated because he had put a lot of time and effort into explaining it to me. And then at the end of the night, as I was about to give up, I found a 3-minute YouTube video which explained binary numbers, and I was able to understand the concept. So it wasn't that I was just too stupid to understand binary numbers, and it wasn't that my friend didn't do a good job explaining it to me. He just didn't provide the solution that I needed. So ask someone else for help or Google the problem. Don't think it's you, don't think it's them. And remember that you are not the code you write. Take a sticky note and write that on there and put it on your desk. You're not the code you write. Sometimes we associate ourselves with our work and with code so much that we think when our code fails, it makes us a failure. But that's actually not true at all. You not being able to debug your code or you not being able to find a solution has nothing to do with you or your abilities. It could have a million reasons. You're not the code you write. If you can't find a solution for your problem and Google can help you either, and you don't have a friend available at the moment, there's other places you can turn to. Obviously, you can go on Stack Overflow. A lot of projects also have IRC channels or Slack channels. The Django girls also have a Gitter chat. They also have a Slack channel. The PyLadies have a Slack channel where there's a lot of friendly people that can help you. I think that Twitter can also be a good debugging tool, if you will. Post the question on Twitter and use the hashtag Python and Django or whatever you're working on, and sometimes a lot of people will chime in and they will help you. And especially in the Python community, everyone's so friendly, so don't be afraid. And when your code finally works, I hope you'll do the happy dance. That's all I have for you today. I won't be doing a Q&A because I prefer chatting with people one-on-one. So if you have any questions, you can tweet me at OSSAnna16, or I'll be around after my talk. So please come talk to me. And if you like a rubber duck, please come see me as well. I also have PyLadies remote stickers and Django Girl stickers with me. So if you like a sticker, come see me too. 2 more things. So we're always looking for new PyLadies remote teachers. All of our classes are remote screencasts between 1 and 3 hours long, and we do 1 class a month. If you'd like to teach a class on anything Python related, please reach out to me. And we do welcome male teachers too. You can follow us on Twitter at PyLadies Remote, or here's our website. So please reach out to me, and please check out our website. We have resources of past classes on our website too. And like I said, it's all remote, so you can teach or watch with your pajama bottoms on and no one will notice it. And another thing, as I said, I'm currently looking for a new work opportunity. So if you are looking for something at the intersection of tech and people, so if you're hiring or your company's hiring or you have any leads for me, I wrote a blog post all about myself and what I'm looking for under this link. So I would appreciate if you know of something, if you'd reach out to me. So now and go break all the things, take them apart, put them back together, fix them, be confident, and always remember that there's a solution for everything. Thank you so much for listening. Enjoy the rest of PyCon Canada. Enjoy the rest of your day, and have a great time here in Toronto. Thank you.